All right, so I am recording this, so you have a review. Is there anybody in here that's not for Nursing 220? Okay, I'll take the silence as being that everyone here is from Nursing 220. The first thing I want to do is just go through some of the questions that Professor Wright had indicated were commonly missed on this test. So there were quite a few, and then I just want to clarify some of these things. I will not use the exact same numbers, but I will, I'll use the questions for future exams and things like that. So one of the questions was just converting milligrams to milliliters. You're given a label, and on that label, it tells you a couple things. It tells you that a medication is available. So let's just say you're supposed to give 250. I like to write in black. Let's say your order, so we'll leave it at that, is 250 milligrams, and then your available is, let's say it is 200 milligrams per 2 ml. Okay, so that's what some medications are indicated like that. And one of the things I've learned is, in addition, so this, like the 200 over 2 ml will be kind of like in the box and highlighted, but almost 100% of the time right below it, it'll say 100 milligrams per milliliter. Okay, so I'm going to show you the two ways in which you can answer this particular question, and both of those ways can be done doing desired over half. So what you're going to do is, or I'm sorry, order over half. So I'm going to take my 250 milligrams over, I have 200 milligrams times the 2 ml. So that's one way to solve this problem. Or you can do the 250 milligrams over the 100 ml, 100 milligrams, sorry, times the 1 ml. Either way, you're going to get the exact same answer. So when I do that, I'm going to plug that into my calculator. So 250 times 2 divided by 200, and you'll get 2.5 milliliters. If I do the same thing here, 250 divided by 100 is 2.5 milliliters. So notice that my answer is the same no matter which one you use. The important thing is that you use one or the other. So enough people must have missed this question that Professor Wright would have given this to me. The medication that they that was highlighted was some sort of an antibiotic, and I just want you to be familiar with that. Does anyone remember that question? Remember missing it or having trouble with it?
I remember the question.
Okay.
Apparently I missed it too, but I don't know why, because I feel like that's an easy one.
Yeah, and so sometimes what happens with these ones that are easily missed is that it just, for whatever reason, numbers get mixed around. So maybe, you know, I don't know what happened, to be honest with you. So just make sure you double check your work before you come up with your answer. I'll agree with you. I don't know where certain people went wrong because I don't have access to everyone's test and where they may have gone awry. All right. The next question actually was the one that Jimmer, you had asked me about. So let me, I've actually done a couple iterations of this already online with, so I'll give you some practice problems for this. So this is a flow rate question. I don't know why I keep wasting that. So whenever you're calculating flow rate, okay, in order to calculate flow rate, you need two pieces of information, okay? You need volume and you need time, okay? In order to calculate flow rate, you only need volume and you only need time. Now, in nursing, we're going to be typically talking about milliliters per hour. Okay, we're going to have milliliters per hour, and sometimes we're going to convert that to drops, and so we would have our drop factor, which is drops per milliliter. Okay, so that's really the only caveat there is for the flow rate. So one of the questions you had, and this I've had multiple variations of this, so let me pull up the things, because this also was a problem for the 240 class. So give me 1 second while I pull up my email. All right, so let's start off with there's a couple of, okay, yeah. So let's say it says something along these lines. Your patient who weighs 128 pounds, so a 128-pound patient, is to receive Solumedrol 200 milligrams IV. Okay. It is received in the pharmacy in a bag that is 240 milliliters, and it's supposed to infuse for 2 hours. And it also gives us a drop factor of 15 drops per milliliter. The question says no other IVs are running, and it says, what is the correct drops per minute? So when I'm doing this and I have all these numbers, and this is where I'm getting the assumption that you're getting, this is where people are going wrong with some of these things. When I'm calculating flow rate and I'm calculating drop rate, all I care about is the volume over time. The volume is either going to be represented as milliliters or drops, and the time is either going to be represented as hours or minutes. And so when I talk about, patient's weight, I don't care about that, okay? Don't care. Doesn't factor into the flow rate. 200 milligrams, again, doesn't matter because it doesn't factor into the flow rate. All I care about are the volumes. So I care about this to 240 ml. I care about the time, 2 hours. And I care about the drop factor, 15 drops per milliliter. The other information that's listed there, I don't care about because it doesn't affect the flow rate. And so one of the analogies I always like to give for this is, and just bear with me while I go through this, let's say, we're both at CCAC campus and we're both going to take a trip to Kennywood. I'm driving a minivan and you're driving a Porsche 911. If we're both going 45 miles per hour, we're both going to get there at the same time. And other than arriving in style, it really doesn't matter what you are driving. And that's what the patient's weight and the strength of the medication indicate. It's indicating what you're driving. When I'm asking about the rate, how fast did you go? We both went 45 miles per hour. That is all I care about. It doesn't matter what you're driving. It could be a bus, a minivan, a moped, whatever it is. I only care about the rate in which to calculate when I'm doing these things. So how do you solve this question? Well, you just take the rate of 240 milliliters over the time. Now I'm going to do a shortcut. 2 hours is the same thing as 120 minutes. Is everyone okay with that? Times my drop factor. When I do this calculation, I get 13 drops per minute. Now, if you're trying to do desired over have or order over have with these questions, that might also be a problem where you're running into. You can do that, but you're going to have to remember to do 240 ml per 2 hours times 15. You just have to remember to do that. And I think that might be a sticking point for some things. And so the formula that I like to follow, if you don't like dimensional analysis, is just flow rate times drop factor. That's all I'm following. And just make sure your hours are converted to minutes before you move forward. Let me give you another question that's just like this. Give me 1 second. Okay, let's say someone was ordered, and let's get into some specifics. Let's say someone was ordered Lasix, okay? Lasix for a heart failure. So it's 350 milligrams IV. The available dose is Lasix 100 milligrams. So this is the order here, and then this is what's available, the 100 milligrams. And then it also says something very conflicting, and it says 40 milligrams per milliliter. Okay, so what this is this is the total strength available, and then this is the concentration. So when it asks me to calculate milliliters, I want to follow my order over milliliters. So I told you we were going to do another drop rate question, but I'm taking a variation of this just to kind of show you when you have information that you do not need in order to solve the equation. I really don't care about the total strength. What I care about is the ordered amount and the concentration, because that's the only way I can go from my order over my have to get my answer. Okay, so 350 divided by 40 will give me 8.75 milliliters. But that's not the answer, right? We know that the answer would get rounded to the nearest tenth, so your actual answer would be 8.8 milliliters. Whenever you are doing like drug calculations where you're actually doing drug math, you always want to round to the nearest tenth for numbers that are greater than 1, and round to the nearest hundredth for numbers that are less than 1. So if this were 0.75, you would just leave it as 0.75. Let me go back to a variation on the flow rate that can also be tricky, but I'm going to show you how to kind of navigate so you don't use the wrong information. I have a IV of 1 liter of D5W that's infusing at 100 milliliters per hour. The drop factor is 30 drops per milliliter. And the question is, what is the drop rate in drops per minute? So now you have 2 volumes listed here, okay? So this is how I rationalize this, and maybe this is helpful of having a visual. So let's say I have a patient. They're hooked up to the IV, and the IV is sitting up here, okay? And this IV is the 1 liter IV solution and whatever's in there, Okay, most likely it's just what? Normal saline, help with hydration and things like that. And then typically this is plugged into some sort of device that has a readout, and that readout tells me the 100 milliliters per hour, right? So this is kind of standing there. There's buttons here that you can kind of go through and set and change the dials. You can, you know, affect the infusion rate. Is everyone kind of seeing what I'm saying here? Does that look familiar to you, like in the clinicals you guys have done?
Yes.
Okay. So I know that my image is not to scale. Obviously, the person's not in the bed, and usually you don't do, you know, nursing on stick figures. So the reason I bring that up is because, again, do I care about the total volume when I'm calculating flow rates? And the answer to that is no, I don't care. I don't care that it's 1 liter. It could be 500 milliliters. It could be a 2-liter bottle of cola. It doesn't matter. All I care about is the flow rate and the drop factor. Now, the only reason this would be important to me is if it told me 1 liter and then that was to diffuse over 6 hours or infuse over 6 hours, and I didn't have any other flow rate listed, then I would care about that, okay? Because that would be the only way to calculate an infusion rate. But when they give you the flow rate, 100 milliliters per hour, and then, sorry, I like to write in black when I'm writing 100 milliliters per hour is your flow rate. I'm going to simplify this and write 60 minutes. It's supposed to be a 6, not a G. Times your drop factor, which is 30 drops per milliliter. Notice that every single time, I'm always going to do flow rate, preferably in milliliters per minute. Sometimes it's milliliters per hour. And then you're going to get your 50 drops. If I can write your 50 drops per minute. Okay. So that's how you do these types of flow rate questions and how you ignore or know how to avoid what is given to you. Okay. Sometimes, and at least for the question that I just gave you here, it won't be written where there's like multiple volumes and multiple times or anything like that. It usually is very clear. It's just a matter of you navigating through it. Okay. All right, let me go through the next question that was missed on this test. Okay, strongest concentration. And I have a feeling what happened here was this. I think you guys know how to do this problem. You've done it multiple times. What you saw was something that looked like this. You had 25 milligrams per milliliter. You had 15 milligrams per milliliter, and you had 10 milligrams per milliliter, and then asked you to choose the strongest concentration. And because on the practice test, it was always the last one, the third one listed. Remember, the strongest concentration is the one that has the highest number per milliliter, okay? So if I were to write this also like this, I know when I do this, you sit there and go like, yeah, I get this. I'm not an idiot, but people miss this. So, and I saw what was circled. So I have to assume that what was circled was just, you made a guess because of the anxiety of taking the test of which is the strongest concentration. Because the math was correct. It's just that your answer was wrong because you did not use the strongest concentration. So just pay attention to how that's written out and make sure you choose the number that's highest per milliliter to answer that particular type of question. And then you just do your math. So let's just take, like, let's say I have 70 milligrams as the order. I want to know how many milliliters. So I would take my 25 milligrams per milliliter, and then 70 divided by 25 would be 2.8 milliliters. All right. Well, let's look at the next question. All right. The next two questions had to do with flow rates as well. Okay, so this was a heparin type of question. And then actually, they were both heparin style questions. And basically, it was converting units per hour to milliliters per hour. Now, the secret to this is a lot of times it will always give you these pieces of information, regardless of what it is. And again, you can do this with desired over have. It's just you got to orient it up correctly. So units, the way I would set this up, units per hour times milliliters per unit will give you milliliters per hour. The reason I say to do that is because it just helps to organize the information. But I'll show you some of the variations in which people solve this particular type of question. There's not one wrong or one right way to do these things, as long as you're getting the right answer. And obviously, if these were circled, it means that some of the answers weren't working out so well. Now, the first question was, and you had this on your practice test. Let's say I have 500 milliliters of an IV that's infusing with heparin, 25,000 units. Always seems to be 25,000 units for heparin. And it's infusing at 500 units per hour. And I'm just showing you how I would set this up. I just would go in order of the quiz, or of how it was stated in the question. And the reason I'm setting this up too is, like, you can see that we eliminate units, left with milliliters per hour, and then it's just a matter of 500 times 500 divided by 25,000. Let me see what that comes out to be. 500 times 500 divided by 25,000 will give you 10 milliliter per hour. Now, what if the question had said something like this? There's 25,000 units in 1,000 milliliters IV, and it's to infuse at 200 units per hour. I would still set this up in the exact same way. What happens though is, I think a lot of times people will say, oh, well, they mentioned units first, so that means I need to write this as 25,000 units per 1,000 ml. Now, if you do that, you're not wrong. It is units per milliliter, but you also need to know that it's okay to flip to 1,000 ml over 25,000 units. The ratio is the same, okay? The ratio is the same. You can flip those over. They can be interchangeably flipped and manipulated however you like. But if you set it up your problem with it starting here, you will get the wrong answer 100% of the time, okay? That's one of the reasons why I'm an advocate of dimensional analysis, because it helps you to organize the information so you don't make those mistakes. The other thing that seems to be helpful is, let's say I take the information, because I said 200 units. If you start with the 200 units per hour, let's say you write it like this, and then just divide by the 25,000 units times whatever your IV solution is, and I said 1,000 milliliters, that is how you would set that up if you were doing like desired over have or order over have. That would be what that would look like, okay? And so that would be perfectly fine if you're setting it up just like that. It will work out for you every single time. So like I said, there's more than one way to set these problems up. I just want to make sure that you're setting them up the right way when you go in and take this, take these quizzes or these tests. Now, the other thing that was similar was, what if it gives you milliliters per hour and asks you to convert it to units per hour? You're going to do the exact same thing. You're just going to use a different variation. So 500, let's use here, again, we'll use the same kind of stuff. We'll say 1,000 milliliters of an IV solution. And then we'll say 25,000 units of heparin. And it's infusing at 100 milliliters per hour. And then my question is, how many units per hour is it infusing at? Okay, so we kind of just are doing the reverse. So again, if I were doing this, I'd probably always start with my flow rate. I'd start with the 100 milliliters per hour. Divide it now by the 1,000 milliliters, and then multiply it by the units, 25,000 units. Okay, now when you do this, again, I feel like the way I just wrote it, to me, seems like a little disingenuous to you, because you may not know how to manipulate your questions to get it into this orientation. So I would prefer to show it to you in a dimensional analysis way, where I would still start with the flow rate, the 100 milliliters per hour, but I would just write it a little bit differently. And then my units, which are contained in the 1,000 milliliters of the D5W. The reason I like to show it this way again is because now I can eliminate the units that I'm getting rid of, the milliliters, and I'm left with units per hour, which is what the question was asking for. And then when you do your calculations, you just do 100 times 25, and you get 2,500 units per hour, which sounds like a lot. So I hope that's helpful for those types of questions that were missed. What other questions do you have?
I have a question just about what we just went over here, unless I misunderstood. But I don't have my packet in front of me, but I think the questions from like the practice tests are maybe like 22 and 23 or 21 and 22 or something like that.
Yes.
Where they would set up a question similar to what you wrote, and it would either ask for milliliters or units. And I watched some of the videos on your YouTube channel where it was more or less saying if it's asking for units, put the units on top. If it's asking for mLs, put the mLs on top when you're doing the, like setting the problem up. Is that like what this is?
Correct. Yeah. So because I know, so this is what I rationalize. I say I'm going from one flow rate to another rate. I'm going from milliliters per hour to units per hour. And so since I usually start with the flow rate first. So what happens is it puts my time in the denominator where it should be. So what I'm saying is it keeps this where it should be. And so I start with my flow rate, and then also just as a theme, I've always said flow rate times whatever, drop factor, or just to kind of get that in the habit of writing out your flow rate first. So I start with my flow rate, and then because I want units per hour, that's where I say like units goes on top, because that's what I'm looking for, and then what you're getting rid of goes on the bottom, essentially. So on the YouTube videos, what I most likely did is I wrote this in the opposite order. I wrote it out like this. I said 25,000 units per 1,000 ml because I wanted the units, and then I multiplied by the flow rate. But basically, I'm saying the same thing. I'm just reversing the order when I do that. So like I said, there's no one way that does it right. Both of these come to the same answer, no matter how you set it up. But if it was helpful for you to do it, to keep in mind units first or milliliters first, then do it that way. And if it's more helpful to start with your flow rate first, then I would say do it that way.
Okay. Yeah, I think that helped. The way you just did it here on the bottom is the way that I did it on the test. It just seemed easier for me to remember, like, what they're asking for is what goes on top.
Perfect.
So I set it up that way.
And then I would also add, keep in mind, like, so the question I gave you said that you had 1,000 milliliters D5W containing 25,000 units of heparin. You got to keep those numbers together. Notice that I keep those numbers together. Don't separate those two, because you could easily put 100 milliliters down here and then 1,000 milliliters per hour, and you can confuse where those numbers go. But notice that I kind of keep these two things together, the 1,000 mil and the 25,000 units, and then I keep this together by itself. So I have two separate things that I keep. When I say keep together, I mean one's a numerator, one's a denominator, and I don't mess with that. Are there any other? Oh, go ahead.
I said I can dig it.
Okay, good. Can you dig it? All right. Are there any other questions? I know you had asked me about like rounding. Did I address that for you, or do you have any questions with that?
There was a couple questions on the test that had some rounding. I know one was, I don't remember what the question was, but I know the answer came out to be like 74.9999. I think it was mLs, and I rounded that to 75.
Okay.
That was one I missed or not. And then there was another one, which I kind of think you touched on in an earlier question, but the answer that I got was 4.125, and that kind of threw me off a little bit, and I wasn't sure what to do with it. I'm pretty sure that's one I got incorrect, but I guess that would just be 4.1.
Correct. Yeah, and then you most likely got you rounded up to 75. You got that one right, because a lot of times, like if you do like if I do 25,000 divided by 1,000 equals then times 100, sometimes it'll give you that 0.99999 difference, which is why I recommend multiplying across the top first and then dividing by the bottom second. And then you'll less likely have those 0.99999. But if you have a 74.99999, your answer is 75. So you did those right. And then you're right. If you had just left if it was 4.125 and you left it at 4.125 or 4.12 or 4.13, the answer should have been 4.1. And most likely that actually sounds like an answer that I would have had for like the Heparin protocol.
Okay.
All right. Are there any other questions as my voice breaks?
Yes, I have a question.
Yes.
And this question is going back to something you covered that I really never thought was a problem, but I don't know if I just got the tail end of it. When you were explaining about the questions about the greater concentrations.
Yes.
All right. Now, you're saying the greater concentration is the highest number in milliliters?
So let me draw it out. So what I'm saying is the highest concentration is so let me just draw out three numbers, and you tell me which one is the higher concentration. So 100 milligrams per milliliter, 200 milligrams per milliliter, and 50 milligrams per milliliter. Which one's the highest?
The highest is going to be 50 milligrams. No. Excuse me. The highest is going to be 200 milligrams per milliliter. Yeah.
Correct. So it's the quantity per milliliter. So, and then this is the way like I kind of rationalize this and break this down. Do you ever make like like the lemonade, like that scoops out like lemonade or iced tea mix or anything like that? You ever do that?
I'm pretty sure I have.
Okay. Okay. So let's say I'm making lemonade. Okay. I have a gallon jug of water, and I'm gonna add so many scoops of my lemonade mix in there. Okay. So this is my pitcher, my gallon jug. There's a reason for this. So this is not completely like off kilter. Okay.
Okay.
So if I do, let's say what the recommendations are. So this is, like I said, this is a gallon jug of lemonade or water, and I'm going to add 8 scoops of this. Okay. So 8 scoops is what is the recommended scoopage for that. So that means I have 8 scoops per gallon. And that's going to be a certain level of lemonade flavor. Now, let's say you got somebody who decides instead to put, let's say, 6 scoops of water, or of lemonade mix into the water, and it's the same gallon. Is that going to be more lemony or less lemony?
Only less lemony.
Yeah, it's going to be less lemony. Now, let's say you got somebody who's going to put in 10 scoops of the lemonade. Now you're going to get an even stronger lemonade flavor, okay? So that's why I was saying, like, when you choose the number that has the greatest number per milliliter is going to be the greatest concentration or the strongest concentration. Does that help?
Yeah, that does help. But in particular, when being more specific, I guess it's the question on the test. Like I can say, I don't know if I may have got these right. I always usually get them right. It's just they're always a little confusing to me. And it's when it goes into the as far as the milliliters dilute, it says it's question 21.
Okay.
They're always asking for. Can I read question 21 to you? Or
Absolutely.
Okay, question 21 reads. It says wow.
Is it Pfizer pen?
Yes, that is
Okay.
Pfizer. Okay, so question 21 looking like, wow. Maybe I shouldn't read that one. No. Let me see. So Pfizer pen at 350,000 units. All right, IM stat every 6 hours. And it's using the information below. Choose the strongest concentration and determine how many milliliters you will administer to the patient. And it gives you the milliliters diluting added.
Just make.
Okay.
Am I writing these out right?
You are writing those out correct. 3.2. Okay. The other side is 250, 500, and 1,000,000. You got it.
Okay.
Now, usually whenever I say, if the question is asking, choose the strongest concentration, the strongest concentration is with the less diluting added.
Correct.
So the strongest concentration, I always pick the lesser number in milliliter.
Okay. And we're just looking at the same thing just differently. So let me go back to the lemonade real quick.
Okay.
And so let's say I had 8 scoops, but instead of a gallon, I'm only putting 8 scoops into half a gallon. Right?
Yes.
There's less water but more powder. And
yes.
And you're looking at that exactly the right way. Now, but when you're solving this particular question, all this part of the table tells us is how much of the water to add in the pharmacy to the powder to get to the corresponding concentrations. So when you're doing your math, you just ignore this column.
Gotcha. Okay, because you're just picking that number. You're just making sure from that you're picking that 1,000,000. And
correct.
So you're taking that 1,000,000 and you're taking that 350,000 and dividing about that 1,000,000.
You got it.
Okay, yeah, because I say I usually get it right, but it's just like it's one of those things where out of habit you get right. And if we're going to expound on some things here, you know, let me get that one in too. But okay, so and that all right, cool.
Yeah, I think a lot of times what happens with these types of questions is like you get so used to doing the hard questions that you're looking for the trick. And then for this one, the trick is just to ignore the milliliters diluent added, or like you're using it as a guide to tell you which one is the strongest concentration. As long as you don't factor in the milliliters diluent added into your equation, you're doing it right.
Okay. All right. Good.
That's what I was trying to do. I was adding the milliliter diluent.
Okay. No, and that's a common thing that people do, is they will add the milliliters diluent added and try and figure out what that is. So here's how, the reason it's written like this is like, let's say you're looking at a drug label, and on the drug label for constitution or reconstitution drugs, it'll tell the pharmacy how much water to add to get to a given concentration. So that seems to be the case for like Pfizer pen, okay? In other things, a lot of times it just says fill to the line to get to 250 milligrams per milliliter for cephalexin or amoxicillin or whatever the case may be. And a lot of times, like as a consumer or as a patient, you actually already get it pre-mixed. So there's nothing you need to worry about as milliliters diluent added. However, if you are a nurse working in like an assisted living facility, you might be the one mixing some of these concentrated elements. And so you just need to know how to add, you know, the volume that it tells you to add of deionized water to get to the concentration. Now, for math, I don't care about the practical aspect of, you know, adding the volume. I'm just going to assume that's already been done, and I'm just going to look at the concentrations. So the units per ml, these are your concentrations. And that's what you want to pay attention to.
Gotcha.
Now I get it.
Okay, good. Good. That's good. Yeah, I'm sorry that you didn't get that before, but I'm glad you're getting it now. So
I think it was because they're small numbers. Like if you're in the hospital and you're concentrating something, for an IV, generally you'd be using like, sorry about that puppy.
that's okay.
Generally you'd be using like 250 mLs of a solution. So I couldn't figure out why we were only using 18.2 to dilute.
Okay.
So now that I know I don't have to look at that, I get the problem.
Yeah, and if you think about it, look at the units per ml, like you can see that you get a big bump from a little amount of milliliters. And that's what they're trying to basically say with like Pfizer pen, and there's some other, obviously heparin falls into that, you know, insulin falls into that. You only need a little bit to have a maximum effect, as opposed to like when you're giving somebody an IV solution of like normal saline and they're getting like, you know, 500 milliliters an hour, or, you know, whatever that is. I don't know if that's right. They need a greater quantity of that because they have a greater quantity of blood, as opposed to the mechanism of the drug, which is some drugs need a little bit less and some drugs need a lot more.
Thank you.
You're welcome. Don't you wish they would just tell you these things in class?
It would be really nice. Of course, you know, it would be nicer if they would realize that they do this in the pharmacy for us. Oh,
yes. But like I
that's
said,
awful. I shouldn't think that way.
that's okay. Well, no, I've had nursing students that were LPNs that were working in like assisted living facilities, and they would say like they actually are the ones doing the mixing because there may not be a pharmacist on staff. And so they have to kind of do their own reconstitutions, which is, you know, what is involved with that. And sometimes you get taught something that maybe you will never use, but it's because there's that field of people that do use those things. So I'm a chiropractor. That's what I do. Like that's in addition to being an adjunct faculty at CCAC. And while I was in class in school, I learned how to deliver babies. I learned how to do phlebotomy. And that is way outside of the scope of my practice. In Pennsylvania, it would be illegal for me to do any of those activities. However, if I were living in the Western states like Oregon or something along those lines where there's a deficiency in the doctors there, my degree has to satisfy those requirements. That way I could practice over there, and I might have to do some of those things like draw blood or deliver a baby. But obviously I don't need to worry about that here in Pennsylvania. So the same thing occurs with nurses and the nursing education as well. So don't get too frustrated.
I think it's more of I need to change my mindset from working in a hospital with a lot of nurses that say these things to learning how to be a nurse that can do it.
Correct. You got it.
Okay. Wow.
All right, I'm going to go practice now. So thank you very, very, very much for doing this.
Yep, you're very welcome. And I will post this review on my YouTube page. And so you can revisit it if you like to, and the other videos that are on there as well.
Okay,
Well,
wonderful.
How long is the tutoring session?
I usually just go an hour. So, so if you have some,
I got about 13 months. Let's have at it.
Yeah, go ahead.
All right. Now, one thing that I didn't even attempt, because I never got that, you still there?
Yeah, I'm still here. Sorry, I'm listening.
All right. One thing I never attempted was the big question.
The Heparin Protocol.
Well, no, is that what it is? The protocol, the bolus, the patient with the heparin, yes.
Yes.
All right. Now, that, I've never seen that before.
Okay.
This is my first time I've never seen that. And I have that question, and I think you may have helped with the going from units to milliliters. I was stunned at that. So I think I missed like 4 that I just kind of sat there and said, I'm not going to do these.
Okay.
So, I mean, because it's like there's no need. And I said, well, because I'm not prepared.
Okay.
Right? And it's like, but that protocol, like, what is this? I've never seen this until a young lady shot me this screenshot of what I have before me, the number 25, the protocol, the bolus patient with the heparin of 80 units by kilogram body weight, and the start drip at 18 units per kilogram an hour. And the patient's weight. Now, one thing, the patient's weight. So the first thing I would do, I guess, is convert the pounds to kilograms with the old trusty 2.2 divide, and go from there. And so I guess I did that and got, 50 kilograms. And then the rest.
The rest you're unsure of.
Yes. Because I've never had this question done.
All right, so let me help you out. So first of all, I want you to know, and this would be good for future, like, because you're 3rd semester, so there's some 4th semester reference on this as well. But if you do a YouTube search or a Google search for Dr. Rad, the Rad tutor, you'll see my picture, which is the picture that shows up when I talk. And I have all these videos, including the Heparin Protocol video. So if you look at, like, I have playlists, and you'll see, like, the Heparin Protocol worked out. So I was handwriting it and videoing that. And then I'm going to also show it to you right now as well. So
okay.
I just want you, I want you to know that you'll have access to that as well. So let's go ahead and go through that together.
Yes.
So first of all, with the protocol is fairly standard. So, like, if you do a Google search for Heparin Protocol,
Yes.
you're going to see where it says steps 1 through 15. That's basically like a standard protocol. Now, you do not need to worry about filling in all the data that's located within the steps 1 through 15, meaning like step 4, it says CBC initially and repeat every blank days. You don't need to worry about filling that in. Okay. to answer this question, you just need to go down to the bottom where it says answer the following questions, and then it tells you to calculate the bolus, calculate the infusion rate, calculate the bolus again, calculate the infusion rate again, in where it says A, B, and C. And so that's what I'm going to show you. Okay.
Gotcha.
Now, and then I'm also going to help navigate where I'm getting the information to do this, so that way you know how to do it again in the future. So I always tell you guys, and fourth semester, because you'll see it again in fourth semester, really the only thing I can change on the heparin protocol is the patient's weight. And so you can just practice after I show you the 110-pound patient, you can just practice with a different weight patient. So, all right. So you already answered the first part, which is kilograms. Yes. Now, as an aside, if you were to get something like, let's say you got 72.2323 kilograms, you would round that to the nearest tenth. So just do 72.2 to do your calculations that we're doing here. So that's just kind of like an aside, just to keep in mind that you want to round that to the nearest tenth. Okay. Okay. So to the nearest tenth, it would be 70. I guess just 72. Well, 72.2. Oh, 72 yeah. Excuse me. That's going to be 72.2. Correct. So, and you might see that sometimes you have like 45.45454545, and you would just round that to 45.5, and then do your calculations based off of that. So now that's going way back. Now when you're rounding something to the nearest tenth, that means you want the tenth to show? Correct. Yeah. Okay. Because that, like, again, we're going back many years with this. Yeah. Okay. 72. So we round it to the nearest tenth. So if they said they wanted to round it to the nearest hundredth, then you would want that, and it would be 72.23 in this case. Correct. But okay, for you guys with nursing, yes, if you have a number greater than 1, you're typically going to round to the 10th. And if you have a number less than 1, you're going to typically round to the 100th. The exception to that is if you have like drops, and drops are always in whole numbers. Okay, so I would just write that down. If I have a number that is greater than 1, if I got a number greater than 1, I round that to the 10th. And if I have a number less than 1, then I round that to the 100th. Gotcha. You got it. Okay, now that's just a little something to cloud my mind up a little bit more with this upcoming exam. I don't think it'll be a problem for you, because you're probably already doing it. So like that Pfizer pen question you asked me, the answer to that question is 0.35. So I think you said 350,000 units, and you wouldn't round that. You would just leave that there because it's a number less than 1. Yes. Okay. But then if you had something that was like, let's say it was 2.35, then you would go ahead and round to 2.4. Does that make sense? It makes a lot of sense, because I forgot all about that old golden gem. Yes. And see, I guess the more we take these dosage calculation exams on the first day, the weaker we become. yeah, as it thoroughly demoralizes you and puts you in a hole. Yeah. Okay, got you. You know more of this stuff than you like are. It's just a matter of like refreshing your memory. Yeah, exactly. Like refreshing, and usually I'm good. I usually before dosage calculation exam, I look at the information. I may spend an hour on it, and I'm good. But this here, it's like, whoa. I could spend a couple hours. I've never seen this. Especially then I said, well, maybe that's the one you get wrong. And it's just like, well, no, that's not cool. You have to. And then I messed up with I don't know, it was a lot of the questions where you're setting up and what are you priming the machine at and so on and so forth. I'm thinking like, wow.
You know, I only took med surg once, no, but there's no excuse. And so it's just I just go forward.
And I want you to know also, like, I do these reviews the week before classes start every semester. So so like next semester, you know, you hit me up, and I should be doing it in the spring. And then I've also on my YouTube page, I work through, because you're gonna have pediatric dosage math this semester as well. And I went through the practice test on those as well. And then I'm sure that Professor Kowalski will ask me to probably do a review for that as well. So
now whenever we transition from mental into pediatric, are we going to be required to do a dosage calculation exam that going into pediatrics, or is it just one per semester?
it's just part of your it's part of your quiz or one of your quizzes at some point during the semester. So it won't be like you need to know how to do it, because there's some different rules to follow with pediatrics.
Gotcha. I guess, yeah, you're going smaller.
Yep, you smaller, so you have a smaller mass, and also you have a higher metabolism, and so the way they have safe ranges in which they metabolize what is safe to give a kid. Like, you can't give a kid like a full dose Tylenol. That's why they have like things like baby aspirin or children's acetaminophen and things like that. Or you do microdosing, so you use smaller quantities. You wouldn't want to give like a kid like 2 full strength or 2 extra strength Tylenol. Like if they're really young, that could be problematic.
Yes.
All right. So let's go ahead and go through this heparin protocol together. And then what I'm going to do, since you have it in front of you, I have it in front of me as well. And what I'm going to do is just kind of call your attention to different components. And then I'll also write where I'm getting the information from here as well. So the first question where it says A, and that's why I denoted A, it says calculate the number of milliliters to administer for the bolus. So I have to go back to the initial statement that says bolus the patient with heparin 80 units per kilogram body weight. Do you see that?
Yes, bolus yes.
Okay. That is also repeated in step 10 of the protocol. So if you go down those numbers 1 through 10, and then 10 says bolus with 80 units per kilogram.
Yes.
So in the event that the protocol is missing, it's in the protocol itself. So the protocol is the steps 1 through 15. Okay.
Okay, so everything within the protocol is 1 through 15, but they actually break it down after that. The 1 through 10, or the 1 through 15 is just the breakdown.
Correct. You got it. And
Gotcha.
And the way I look at it is it's almost like the practical thing that you would do if you were like working in a unit that does heparin. And you would basically be following these guidelines while you're treating the patient.
Mm-hmm.
Okay, so I'm going to take the patient's weight, and I'm going to multiply it by the bolus dosage strength of 80 units per kilogram. Okay, and the reason I'm doing this is I'm basically just accounting for the weight. I get rid of the kilograms, and I'm left with units. When I solve this, and I'll say go ahead and solve it, you'll get 4,000 units as your answer.
Gotcha.
Now, if the question had asked you how many units to administer for the bolus, you'd be done. Okay, but unfortunately, it doesn't say that. It says how many milliliters to administer. So I need to go back into the protocol and find out what my bolus dose strength is. So if you go go ahead.
I'm listening. Now I was repeating what you said, bolus strength. Okay.
Yeah. So in order to, just for simplicity's sake, all you're going to do is go and look at step 2 of the protocol. And step 2 of the protocol tells you heparin 25,000 units and 250 milliliters, half normal saline. And then it says bolus dosage strength 1,000 units per milliliter. Are you seeing that?
I'm looking right at it.
Okay, perfect. So we're going to take that bolus dosage information. I don't want units. I want milliliters. So this that I just wrote here is the information from step 2 for the bolus strength.
Okay, I'm writing that down. So step 2, which is my bolus strength. All right, let me see my bolus strength. Okay. My
And then
bolus.
when I do that when I do that math, so first of all, I'm getting rid of units and I'm left with milliliters, which is exactly what I'm looking for. And so my answer is 4 milliliters.
Mm-hmm. Okay, so you continued, all right, because you had units. Now you cross units out, you cross those guys, and now you're looking for milliliters, and you multiply the 1 times the 4,000. Oh, you took one. Okay, you got rid of the 1,000, and so now you're left with 4 milliliters.
You got it. So all I did was I did 4,000 times 1, which is itself, divided by 1,000.
Uh-huh. Let's see. Got you. Because I'm going to work this. I'm taking everything in. I'm going to play with it.
Yeah, no, that's fine. That's what I want you to do. I want you to practice it. So now B says so that we're actually going to practice the bolus and the infusion twice. On your test, you're only going to get one or the other, meaning you're only going to get AB or you're going to get C part 1, part 2. Okay, and I'll explain C once we get there in just a minute. Now, part B says to calculate the infusion rate in milliliters per hour for the IV drip. So we go back to the protocol, back to step 10 or to the initial sequence question, and it says to start the drip at 18 units per kilogram per hour. We don't want the kilograms, so I'm going to take the patient's weight again,
All
and
right.
I'm going to multiply it by that 18 units kilogram hour. And what that does is it eliminates kilograms, and it'll give us units per hour once I do the math. Once I do the math, I get 900 units per hour. Now I'm gonna tell you right up, I know what all this math ends up being because I've done this particular problem probably literally 50 times, and so I have the flow memorized, which is why it seems so easy for me, if that makes sense. And that's why I'm trying to highlight the things that are important as we kind of go along. So I assume that you can do the math just fine. 50 times 18 is 900. So you wouldn't be in the semester you're in right now if you couldn't do the math.
Exactly. Yeah.
All right. Now, again, if it asked us just to calculate units per hour, we'd be done, but it wants to know milliliters per hour. So this is actually good practice for going from units per hour to milliliters per hour.
Yeah.
So I'm going to go back to step 2, and step 2 tells me 25,000 units and 250 milliliters, half normal saline. And so I'm just going to write that out. I don't want the units, so I'm going to get rid of those 25,000 units. And then I'm going to incorporate the 250 milliliters. Again, this is coming from step 2 of the protocol. And this is what my, this would be my, I guess we could just call this the infusion strength.
Mm-hmm.
And I apologize for my handwriting.
Infusion strength.
And so when I do the math for this, I get 9 milliliters per hour.
And 9 milliliters mean, 9 milliliters an hour, and that would be B.
That would be your answer for B.
Hmm.
So to kind of create a summary here, this is the information I would use for my initial bolus. And then this is the information I would use for my initial flow rate. The only thing that I can change on this particular type of question when I do it is the patient's weight in pounds, which would change the patient's weight in kilograms. And so, but I would still, whatever I got in kilograms, times 80, divide by 1,000, times 18, and then this is actually dividing by 100. And that's, I would follow that same flow every single time.
Gotcha. Boom. And you're saying, so as I go through this stuff, this is going to help me solve all the other little miscellaneous questions that are going from milliliters to units.
Right. So like for questions on your practice test, for questions 22, 23, and 24,
Yes.
that's what B is. When you go from units per hour to milliliters per hour, that's the same thing as questions 22, 23, and 24.
Gosh. Okay. So this is the do all be all.
Yeah, it's tying it all together.
So I master this, I master it.
I think so. If you practice it enough and you feel good with the flow, you should be fine. And then also, like, this was what I was getting at earlier in the review. I said I would, if I'm going from one flow rate to another, I usually just start with the flow rate, the initial flow rate, multiply it by, in this instance, milliliter per units to get to my new flow rate, milliliters per hour. And that's the exact same flow you would follow for 22, 23, and 24.
Yes.
Well, not 24. 24 is just, that was like, it starts 8 a.m. on Monday and it ends, you know, when does it end? So just 22 and 23.
Oh, yeah, that's pretty easy. If it started,
Yeah.
I think it got like 20 hours. Because I did the practice sheet, and it would be the next day, early in the morning. But now, one thing that was a little confusing. Hold on. So we started to do C, correct?
Yeah, let's go ahead and do C.
Okay.
So C, what I'm going to do is I'm actually going to clear my screen here. Actually, never mind. I won't clear the screen because I actually want to show you a couple things. What I'll do is I'll do C1 and then I'll clear that out and then I'll do C2. So, so when we do C1, it says, I got to go back to my question here. It says, calculate the number of milliliters to prepare. And then it says C, it says after 6 hours, the patient has an APTT of 43 seconds. Now, in the protocol, steps 11 through 15 is the quote unquote after 6 hours, what to look at. So you look at the APTT after 6 hours, and then you look to see what range or what number applies to the 43 seconds. And notice that step 12 kind of makes some adjustments to the protocol. It says to rebolus with 40 units per kilogram, and then to increase the rate by 2 units per kilogram per hour. Are you seeing that?
Looking right at it.
Perfect. Perfect. So this would be the other thing that I could potentially change. I could change the patient's weight, and then I could change what the APTT is after 6 hours. So like, let's say it was 34 seconds. Then I would do what it says in step 11. Let's say it was 49 seconds. Then I would follow step 13. Does that make sense?
Yes. But because it was over 44 seconds.
Then I would go to the next thing. Yeah. So, but because it's 43 seconds, we're just going to follow what step 2. And step 2 says to rebolus the patient. So I'm going to bolus them again. And it says this time to bolus them with 40 units per kilogram.
Okay.
Now, 40 units per kilogram is exactly half of the original 80 units, right?
That's correct.
So you could just right now, right off the top of your head, you can go, okay, well, half of, if it's half, I started with 4 milliliters, it would be 2 milliliters. And then instinctively, you would be correct. But for math purposes, we can practice, same patient, this time 40 units per kilogram. We get rid of the kilograms, we get 2,000 units. And then I'm going to calculate again by the same bolus dosage strength. I always come back to when I do bolus, I use the bolus information. And when I do infusion, I use the infusion information. So my bolus dosage strength is the 1 milliliter. And I apologize for all the extra stuff here. 1,000 units. I'm actually going to get rid of this stuff here. Okay. And then this is how we get to our 2 milliliters for our new bolus.
Okay, so we. Hmm. 2 milliliters. Well, so that's our new. Okay. Okay.
And that giant.
Huh?
And that giant terrible arrow I did was just to show you that I'm using the same information. I'm still using that 1 milliliter per 1,000 units that I got from step 2 of the protocol. So I always go back to know my concentrations or my strengths by going back to step 2 in the protocol.
Okay, so you would recommend to reverting back to step 2 of the protocol, just to make sure you can stay lined up.
Correct. Yeah. So just remember that's where I'm getting that information from, because when it tells you to rebolus, it doesn't give us a new bolus strength. It doesn't give us a new IV. It just says to make adjustments. And so that's all we're doing.
Making adjustments. Gotcha.
The halftime adjustment.
Halftime adjustment.
All right. Now, C2 says to calculate the new infusion rate. Step 12 of the protocol tells us to increase the rate by 2 units per kilogram per hour. What was our original units per kilogram per hour?
Original kilograms per hour. The original, hold on, kilograms per hour. The original from the start?
Yes. What was the original?
The original was 50. No, hold on. The original kilograms per hour would have been, let's see, it was 80 units. The kilograms per hour would have been 18. Hold on. It would have been 900. Don't tell me.
You're right. Take a step back, but it's just the original units per kilogram per hour was 18, like you said.
So, but 18 units. Okay, I thought you wanted to use the original kilograms per hour.
No,
it's 18 units.
Yeah, no, I wanted the original units per kilogram per hour, which, like you said, was the 18.
It was 18 units per kilogram per hour, which wound up equaling the 900 units an hour.
Correct. Once we accounted for the patient's weight.
Once we accounted for the patient's weight. Okay, so got you.
So if it tells me in the protocol to increase the rate by 2 units per kilogram per hour, and I started with 18, I'm just going to add 2 to that. So what would be my new units per kilogram per hour if I add 2 to 18?
It's going to be 20 units per kilogram per hour.
You got it. So that's what I'm going to do. I'm going to multiply now, instead of by 18 units per kilogram per hour, now it's going to be 20 units per kilogram per hour.
So it's going to be 20. What was that? So there's kilogram per hour. Okay.
And the reason I bring that up is because that's a common misconception of where that 20 units comes from. And I just like to make sure that it's just coming from adding 2 to the initial flow rate. So if it told me to add 4, it would be 22. If it told me to subtract 3, it would be 15. I always base it off of the initial.
But where does it say it? Because I'm looking at C2. It says calculate the new infusion rate in milliliters per hour. Now, where does it actually tell you to add the 2?
So go back to step 12 in the protocol.
I see it there.
Yeah.
Okay, 3 bolus with the 40 units. Okay, and increase rate by 2. So okay, because you had already rebolus with the 40 units.
You got it.
Half of the 8. All right, and you need to increase the rate by 2 units per kilogram per hour.
You got it.
Okay.
And if you look at the other like scenarios, you know, it says increase by 4 units per kilogram per hour, continue current rate, decrease by 2 units per hour, decrease by 3 units per hour, 3 units per kilogram per hour. And those are just what you would do. You just follow it, but it would always be based off of what you started, which is the 80 units per kilogram bolus and the 18 units per kilogram per hour flow rate.
Okay, so A and B are important in that fashion. And so the actual, okay, all right. Gotcha.
Now, just going back to the math, you just do 50 times 20 will give you 1,000 units per hour. And then whenever we're doing flow rate, we just use the flow rate strength, which again was what we did up in step B, which was the 250 ml over the 25,000 units.
Well, and that's the same thing. Okay.
Yep. So it's the same thing coming from the same place that step 2 of the protocol. It's coming from the same place. Step 2.
Always line up like that. A and B are usually somewhat synonymous with C1 and C2.
You got it. Yep. They're basically, you know, A is the bolus, B is the rate, C is the bolus, C1 is the bolus, C2 is the rate.
So A is the ball. Write that down. Okay. So that's the bolus. B is the rate. C is the bolus. And the rate. Gotcha. And so, okay.
And so what I had mentioned, like on your test, you're either going to get A and B or C1, C2. So you'll only have to solve one part of this. So in the Heparin Protocol and the practice test, I gave you basically 2 things to practice. So you're either going to get one or the other. And you only have to solve, you don't have to go through the initial bolus calculations to solve the math associated with the secondary, because you just follow the protocol.
So hold on. So on the test, it's just sinking in what you're saying. So you're telling me on the test, it's going to be either A and B or C and C.
Correct.
So we're not going to have to do A, B, C1, C2.
Correct. You only have to do 1 bolus, 1 rate.
Okay.
So
Wow.
as practice, I gave you 2 scenarios. That way you can have some practice with it.
Okay, got you. All right, so what you've given me is overkill.
Correct.
I mean, no, and I appreciate it because I'm gonna move these numbers around and do what it is I have to do until it becomes solid to me. Because right now it's like, I don't know. I internalize learning. It's just like it. You can show me something, but the way I learn is I have to teach myself. So it's like I just have to take everything outside and then bring it into the small little nest and work it and until I understand it fully. So this is good,
Yeah.
And now as far as the new times of the essence, and I've taken you past your time zone here. All right, now as far as, well, you know what, I'm just going to work with what I have. I mean, I should have it from here because again, everything that was not as familiar to me was this, and a couple of those conversions from units, going from units into milliliters. That was just, it was just a little different.
Yeah,
But
and like you said, it's just a matter of practice, and
Yeah.
and I think that's all you got to do. And if you run into any problems while you're going through like the practice test again or any of the
Yeah.
questions, and you have any other questions, just send me an email, and I'll try and help you out.
What is your email?
Let me write it up.
Okay, cool. Appreciate that.
So I'm gonna go ahead and clear this off. And
Yeah.
like I said, it's all recorded, so you'll be able to get and see this later
now,
on.
Say it's recorded. Like, where do you go to watch it? It be like, where do I go to see its recordings?
I'm going to post it up on YouTube once it populates.
Gotcha.
So that's where it'll be.
Okay.
So this is my email address: DRADZIERCZ@ccac.edu.
Okay. See. Zoom. CCAC.
Sometimes I can type that into the chat too, but I don't know if I can.
Oh, it's cool.
My tablet.
So, okay, that's you, and you said you will. And when I go to Dr. Red, the Red tutor,
Yeah.
then everything's going to, I'll be able to see. Okay, I see. Okay, good enough. All right, well, I'm in there.
Yeah, and you'll be able, once you get there, like on the YouTube channel, you'll see my picture, and then you can see me working out. And I've also posted already some of the other reviews that I did at the beginning of the semester. And like I said, I'll get this up by this evening because it takes a little bit of time for it to populate. So
Okay, and they're saying this test. Well, you don't know when the test is.
I don't know when your test is. I don't.
I don't know. I know. But like, we're doing all this work, and the test was today.
Oh, okay.
No, okay, good enough. I'll get on that information.
Okay.
Yes, indeed. So, well, thanks again for your assistance. I appreciate it all.
Yeah, you're welcome. Absolutely.
And if I have any problems, I'm not going to hesitate to email you.
Perfect. Yeah, I'll email. It just might be a moment till I can respond, but I've been replying to people all this week because I know you guys are trying to get through this test. So
Yes. So is this one of the rougher ones? This one of the rougher semesters that you one of the higher volumes that you've had a situation like this?
only this semester, and I'm wondering if it's just because of the way that this semester is being handled. Like, obviously everything, like you probably have more remote learning going on, and I think it's just throwing people through a loop because in the past I haven't really noticed too many people showing up for like remediation reviews. So I don't know what it is about that, but I would say that the more common thing that's missed in third semester is the Heparin Protocol, because you've never seen it before,
Exactly.
unless you were at one of the earlier reviews. So.
Okay. And a lot of that unit to milliliter stuff. That's crazy.
Yeah, that's new too. So you're right.
Okay. I'm on it. I'm armed. So all right. You'll be hearing from me.
All right, sounds good. And if I don't, good luck on your test.
No doubt. Thank you.
Hey, you're welcome.